Hello, and welcome to the first in a series of informative and educational videos recorded and produced by Pacific Off-Grid LLC, your home for affordable, sustainable, tailor-made living solutions. My name is Gabriel, the 21st century Renaissance man, and today we are discussing Pacific Off-Grid's current project. We are working with Dayenu LLC to transform an 8x20 foot shipping container into usable working space, to include an attic above and an adjoining greenhouse addition for some outdoor but protected square footage. Jeff Capoman Jr. at Dayenu is the lead designer, and Pacific Off-Grid has been brought in to construct the 100% off-grid systems. This video is intended for informational purposes only. Special care must be observed whenever working with electricity. Electric shocks can be fatal. Anyone attempting to replicate the ideas expressed here does so at their own risk. Pacific Off-Grid LLC does not assume any responsibility for any injury resulting from attempting electrical work on your own. Consult with a licensed electrician before beginning any electrical related work. So let's begin. This slide represents the overall concept of the placing for the electrical systems in this container conversion. Having completed the site assessment, the team decided that the east wall of the container and the attic addition above will serve as the best places to house all the necessary electrical components for this installation. This slide depicts the 8-foot wide east-facing wall of the shipping container. This wall is without cargo door, and as a plain container wall, will serve as the location to mount the main service panel, the solar array combiner box, the 30-amp generator inlet, along with all the necessary conduit to house and protect the associated wiring. The battery for the system, the solar inverter charger, and the associated secondary components will be assembled and arranged in the sealed and insulated attic of the structure. The solar array will sit atop the roof. We will discuss each of these components more in depth in the coming slides. So still looking at the east wall of the container, here we zoom in on the plywood backer onto which the main service electrical panel and the PV combiner are mounted. The current electrical architecture will provide the container and the greenhouse with 3,000 watts or roughly 25 amps of 120 volt power. We decided that 120 volt power was sufficient and that 240 volt was not required to meet the simple electrical needs of this project. However, this design would allow for the client to choose to expand to 240 volt power in the future if future demands dictate a need. In order to ensure the highest levels of safety, we are installing dual function, arc fault, and grounding fault circuit interrupter breakers on every branch circuit. And these breakers offer the highest levels of safety available on the market today. Proper grounding and bonding are also fundamental parts of the safety plan of this project. The container wall will get bonded to the grounding circuit, and this will all get connected to at least one 8-foot grounding rod buried to comply with the grounding requirements in accordance with the NEC. Immediately to the right of the main service panel is the PV combiner. This is a smaller circuit breaker box that is used to combine the incoming current from the solar panels and then send that current to the charge controller in the attic of this project. For maximum safety protection, we will also install an optional but always recommended surge protector. Our configuration also provides for a 30-amp generator inlet. At POG, we encourage our customers to consider green alternative sources for energy first, but we also recognize that customers may desire more traditional methods of power generation, such as a gasoline or propane-powered generator. This current design provides our customers with that option, and can also serve as the backup charging method for the battery if weather conditions prevent the collection of adequate power from the sun. Here we are looking at the major systems components of the electrical architecture for this project. The beauty of this design really lies in its simplicity. We strive to empower people with a reasonable understanding of the inner workings of their electrical systems. We want you to know how it works and give you the confidence to at least troubleshoot any issues in the unlikely event that something malfunctions in the future. Power to the people. Again, if you are unsure, you should consult with an electrician. Beginning from left to right, we start with the battery. We firmly believe that an adequately sized battery system is paramount to successful off-grid living. For this project, we are installing a 4.5 kilowatt-hour lithium iron phosphate battery with its own internal battery management and balancing system. We acknowledge this battery chemistry is considerably more expensive than standard lead-acid batteries. However, we strongly encourage our customers to choose lithium-ion batteries because of their dependability, life expectancy, weight savings, safety, and overall effectiveness over all other widely available battery options on the market today. Contact us to discuss ways in which Pacific Off-Grid can help you save money on lithium-ion batteries. Following the red or positive lead from the battery, we have the smart low-voltage disconnect, which can be programmed from the owner's smartphone. Following the black lead from the battery, we will install a battery monitoring shunt that will connect to the smart battery monitor. The battery monitor will be mounted inside the container conversion in a place to allow for convenient viewing. The battery monitor really is an integral part of the system, as power management is a quintessential part of off-grid living. So think of the battery monitor as the fuel gauge for your battery. This is a smart battery monitor, and it allows the customer to monitor the state of charge and the host of other battery performance metrics right from their smartphone. For those with less interest, though, it can simply serve as a reminder to charge your battery with the generator or other power source in the event that solar charging power proves inadequate during protracted overcast weather conditions. However, we really believe that with proper engineering, along with informed power consumption, that this current design will provide our customer with more than enough power for their specified uses of this structure. In the center of the slide is the solar inverter charger. In this specific project, we are using the GrowWatt 3000 watt solar inverter charger. This all-in-one unit combines the need for separate battery charger, MPPT solar charge controller, and pure sine wave power inverter. This unit does it all and allows for the installer to modify a number of different parameters to best meet the needs of each individual project. This unit is also stackable, allowing for multiple units to work together as power requirements dictate, and will allow our customer to expand their system if they require in the future. Once installed, there really is no need for the customer to have to interact with this unit, and this is especially great for individuals who do not feel comfortable playing with it. This can be a set it and forget it concept. Finally depicted here are the other inputs and output to and from the GrowWatt unit. The solar array, the generator, and the AC service panel are all connected to this one unit, further underscoring the simplicity and accessibility of this design, especially for the layperson. This slide represents the concept for the rooftop solar array. This 1.9 kilowatt array consists of 6 315 watt panels arranged into a 3-series 2-parallel configuration. This arrangement maximizes the usable square footage of the roof while providing the entire array with uniform exposure to the southern sun. For grounding safety, the panels and the metal roofing are bonded together via the clamping system that attaches the solar panels to the roof, and then that's connected to the grounding circuit of the electrical system. Imagine now that we are looking at the 8x20 foot shipping container from above. Depicted is the wiring concept for the container and the greenhouse below it. To maximize efficiency, we will install energy-efficient LED lighting along with smart dimmer switches throughout. Dimmer switches not only add a nice touch to allow for the comforts of dimmed lighting, but also they help with decreased power consumption that results from simply turning down your lights. These smart light switches can be operated from your smartphone or by your smart home device of choice. All branch circuits are protected by the dual function circuit breakers previously discussed. This design provides for a dedicated 20 amp GFCI plug in the main area for larger appliance use. We also are installing plugs with integrated USB charging receptacles and can come in USB-C configurations as well. The greenhouse will also have smart lighting to provide comfort and peace of mind during hours of darkness. Overall, this design is modern yet simple. So, if you have any questions, please feel free to leave a comment below or contact Pacific Off-Grid directly with the information provided here. We hope that you found this information useful. Subscribe to get alerts for our next video, where we will be on site to witness the work beginning. Thank you for watching. Blessings to you all.